this is C, and this is D represents. That you have to explain. So in this case, the first graph, x0 is positive and velocity is also positive, right? That means the body is moving in a straight line away from the, at the initial time t is equal to 0, the body was on the x-axis in the positive side and it is moving in the same direction. That means it is moving with the positive velocity. In this case, the body is on the x-axis on the positive side, but it is moving in the opposite direction toward the what? Towards the origin. That means its position is 0. X0 is positive, but velocity is negative. In this case, the body was lying on the negative side of the x-axis and it is proceeding towards the positive side. That means its initial position was negative, right? X0 is negative, but velocity is positive. In this case, the body is moving in a direction opposite to the x-axis, positive x-axis. That means in a direction the negative x-axis the body is moving. And in this case, the position is also negative and also velocity is also negative. So note it down. This is x0 positive, velocity positive. This is x0 positive, velocity is negative. This is x0 negative, velocity is positive. In this x0 negative, velocity also negative. So these are the things about. Then another question I am going to explain you. That is this one. Let me draw this. So yeah. So another question here, it is drawn like this. This is figure number 1. This is figure number 2. Right? In this case, one figure is drawn like this. So it is drawn like this. Okay. This is position x and this is time. Okay. And this is also velocity and this is a velocity time graph like this. And this is a speed time graph. It is like this. It is going like this. Okay. This is speed and this is time. Speed and time. Right. Another one is, this is like this. This is the total path length. Total path length. This is time, etc. This is graph number 1. This is graph number 2. This is graph number 3, and this is graph number 4. Right? Which of the following represents one-dimensional motion? That's the question. Which of the following? Which of the following represents one-dimensional motion? That's the question. Let us see the first graph. In the first graph, whether this you are asked that whether this is representing one-dimensional motion. In one-dimensional motion, when the body moves from the origin, its path length goes on increasing. At a particular time, only one path length is possible. If you draw a straight line like this, right? For this point also, time is same. That time, this is the displacement. For the same time, another displacement is also. At the same time instant, any time t, the body has two positions. One is x1 and the other is x2. X1 is small and x1 is small. So when a body moves along a certain direction, at a particular instant, how the body can have two positions. So this cannot be represented. This cannot represent one-dimensional motion. Right? Next. Now the other thing is that this is the second velocity time graph. Here also we will draw a line parallel to the velocity axis like this. Right? This velocity represents positive and this represents velocity negative. So at a time t second, any time t seconds, the body is moving along a straight line, and at the very same time, how can a body can represent both positive and negative velocity at the same time? Therefore, this is also impossible. This graph cannot represent the motion of a body in one dimension, right? And this is now we are coming to, and this is also speed time graph. Speed time. In the speed time graph, see the speed first is positive, then negative, then positive, etc. See, when a body is moving along a straight line with a speed, the speed is always positive. Speed can never be negative. So this part is showing negative speed. If a body moves in a straight line, executing linear motion, the speed is always positive. Speed of a body can never be negative. Therefore, this graph is also not possible. Next, this graph you see total path length. When time increases, path length cannot decrease. When a body is moving in a straight line and the time is increasing, the path also must increase. So in this case, you see path length is sometimes increasing and sometimes decreasing. That cannot be possible in one-dimensional motion. In one-dimensional motion, if a body starts from the point, it's the path length must go on increasing slowly. But not at any instant that the path length should decrease. So that is why we can say that this graph is also impossible for one-dimensional motion. Another question. So note down all these questions, please. So this is the only possible thing, and also you have to discuss many questions that is given in a reference copy, right? Now I am representing two position time graphs. One position diagram is like this, another position diagram is like this. This is A and this is B. So this is position is supposed to be X and this is time and this is here. Right? Which of the graphs shows which of the which line represents greater velocity? Which line represents what? Greater velocity is the question. Yes. So more thing given is that this line makes an angle 30 degree with the time axis 30, and this line makes an angle 60 degree with the time axis. We know that this is a position time graph. For a position time graph, velocity is the slope. Slope means tan theta. Theta is given to you. Therefore, therefore VA is equal, we can write. VA is equal to tan 30. Tan 30 is equal to 1 by root 3. Why VA is equal to tan 30? Because this is the position time graph for a body A. The slope of the position time graph is it's a velocity. So velocity is equal to the slope. Slope is equal to tan 30. Right? The slope is equal to dx by dt. That is equal to tan 30 is equal to 1 by root 3. And similarly, VB is equal to tan 60. Tan 60 is equal to root 3 also we can write. Am I correct? Therefore, VA by VB is equal to the ratio of the velocities. Sometimes the ratio of the velocities. Ratio of the velocity is equal to VA by VB. That is equal to 1 by root 3. The whole divided by root 3. That is equal to 1 by 3. That is VA is to VB is equal to 1 is to 3. So these two graphs are given to you, and you are asked to find which velocity, which body has more velocity. In this case, the velocity of body B is greater than velocity of the body A. That means VB is greater than VA. And the ratio of the velocities VA is to VB is equal to 1 is to 3. So this kind of problems you also will do. And the next class we will come with a uniform accelerated motion, right? Till then, bye-bye. Thank you very much.